Hello, my name is Paul Underwood. I'm the industry blueprints lead at AWS. Today, I'm going to be talking about demystifying data lakes for healthcare and life sciences companies. Uh, for those of you who joined this webinar today, this might be representative of kind of your life right now. There are data sets that are available to you from different departments or open data sets that you're sort of dying to pull together or query or put into some form of a data lake. And you've also likely got somebody who's interested in security and compliance directly over your right shoulder, like depicted here, who are have vested interest in making sure this data is sort of collected and queried by only those who should have access. The problem gets more complicated as these data challenges often extend beyond your company. You've got consultants or CROs, universities that you might be working with, or external collaborators generally from different systems, like I mentioned, electronic health records or different lab and informatics tools that you may be using, or lab or manufacturing equipment for those of you looking to solve different like GLP and GXP concerns. And the magnifying glass is sort of on you maybe right now to figure out how to pull all this together or define a strategy for that. And I don't think anybody's going to blame you for having a nice whistle and checking out a puppy or a cat video and kind of walking away from the problem for a minute, because it is kind of a daunting challenge. So hopefully we're going to unravel some of that for you today and give you some concrete takeaways that you can benefit from. Or learn about AWS in terms of just the AWS services that can help you build that data lake, and conceptually what you need to keep in mind as you start approaching building a data lake on AWS. We're going to spend a healthy amount of time today in the console doing a few demos. And for those of you who like to follow along, you can initialize your own data lake catalog with some of the open data sets in the Registry of Open Data. We'll show a demo of that for those of you who want to play around with some of these tools today. And then finally, we'll talk about some of those sort of getting started and simplification techniques like the data lake as code, CDK constructs that can take a lot of these best practices that we cover today. It captures those in code, and you can deploy those with your own data sets into your own environment. So the quick agenda, we're going to talk kind of at the high level block diagram concepts of a data lake, kind of emphasizing both what a data lake is and also what it isn't. Then we're going to try to move straight from those block diagrams into something real inside the AWS console. We're then going to try to pull some value out of that, show you how you actually query that data lake and pull some value out of it. And then finally, we'll wrap up by showing you some of the things that we're doing to simplify data lakes on AWS, and we'll wrap up with some final thoughts in a demo of showing you how you can kind of get started today playing around with some of these tools. So as this is a life sciences and healthcare talk, oriented talk, I want to make a couple of notes here about HIPAA and HITRUST, GXP or CFR Part 11, or any kind of compliance regimes that you guys are looking to satisfy. All of the services that we talk about today are eligible for these different compliance regimes. And by that, I mean they all generally support things like encryption at rest, at transit, fine-grained access policies, separation responsibility, versioning, a lot of the things that you would need to either, qualify a service for use among any of these kind of control regimes. Those tools are there. That said, this is all the shared responsibility always applies. We are responsible for securing the platform and making them eligible for these controls. It's really you're responsible for making sure that you use them correctly. So if you're handling PHI, make sure you set up your BAA. You can do so right in the AWS console using AWS Artifact. All right, so let's get into some theory for a moment. So what is a data lake? And again, emphasizing what it is not. There are really 4 areas that we're going to talk about today that sort of revolve around the data lake, and we're going to dive into what's responsible for what in these different blocks. So let's just take a for example data at a high level to begin with. Let's say you have some source data. This could be a relational database. This could be DCF files. This could be, genomic type of data sets. It could be CSV or JSON files that you may already have. That source data gets ingested into the data lake, where it is, transformed to some degree, perhaps compressed or put in a more optimized format, and stored for long-term persistence. Your data access layer is basically your query engine that lets you run your queries against that data as it sits in its long-term persistent form. And then you have your presentation or analysis layer that pulls data from the data lake through the query engine that's in the data access layer. So we're going to go into these into a little more detail. We're going to focus on the first two to begin with, and then we'll focus on the second two at the end. So the kinds of source data that we're talking about, I mentioned structured files, unstructured files, databases, data streams, really just about any type of data that you're able to, process is sort of your source data to begin with. The data lake is really responsible for 4 core things, and a kind of a cheap acronym is MESS: metadata, ETL, security, and storage. Those are kind of the 4 primary responsibilities. The data access layer I mentioned is that query engine, and it also needs to support your common database access protocol that people can write SQL and join the data as it sits in your data lake. And by supporting something like JDBC, ODBC, any kind of application or code or BI tool is going to have support for that, and is going to allow you to query that data through that data access layer. And the things that live in that presentation layer might be just an EC2 instance. It could be your own laptop. It could be a BI environment like Tableau, or the AWS managed BI tool called QuickSight, which we'll show a quick demo of later, as well as notebooking environments like Jupyter and RStudio. These are all viable options to query data out of that data access layer. So we're going to first focus on the data lake portion, and then we're to just set up these kind of core data lake principles. So the first is metadata. The second is ETL, security, and storage. So from a metadata, what do I mean by that? Well, your data is going to be grouped logically into different types of different databases, maybe a database per department, database per project, something to that effect. Those databases are sort of logically made up of a bunch of tables. Those tables have columns in them with different data types, and then that data lives somewhere. It has a location. Those elements combined essentially represent the metadata of the data that you enroll into your data lake. The ETL portion is the extract, transform, and load. That's the mechanism that pulls the data out of the source location and writes it off to its long-term persistent storage location inside the data lake. The security element is basically what gives permissions and the permissions to grant other people permissions. And generally, you're giving those permissions and grants at the database table or column level, right? And we'll talk a little bit more about security at the end. And then finally, storage is that sort of cost-effective, long-term, persistent store where your data lives for, and gets updated in place, and is ideally the most cost-effective way, which is S3, and which is a nice transition to what are the different AWS services that basically fill in these blanks here. From a metadata perspective, it's the AWS Glue Crawler and the Glue Data Catalog. The data catalog is probably the most important service that we're going to talk about today. The Glue Data Catalog is where where I mentioned your database, table, and column definitions and locations are stored. Once your data is in the Glue, has been cataloged in the Glue Data Catalog, you can query it at any time through your data access layer. The way that you populate that Glue Data Catalog is using a Glue Crawler. A Glue Crawler, you sort of point it to your S3 bucket or your database. It will crawl that location, automatically detect your table names, your column names, your column schemas, and populate your Glue data catalog for you. The ETL layer is a combination of using AWS Glue jobs, which you can think of as managed Spark, serverless managed Spark, and then AWS Glue workflows, which lets you stitch together a proper pipeline of crawlers and jobs to build whatever ETL you might need. From a security perspective, as this being AWS IAM, or Identity Access Management, is really the de facto default means of securing your database or your data lake. An AWS Lake Formation includes a number of additional security controls that are much more granular, and we'll talk about more about that in the security section. And then no surprise here, Amazon S3 is the main persistent storage mechanism where your ETL sucks data out of its source and effectively writes it to S3 for that long-term, highly durable, persistent data store. So putting all of these data lake services together in one picture, this is the easiest way to conceptualize it, I think. Imagine you have a data set and you want to enroll that into your data lake, similar to like checking in code to a repository. You want to enroll your data set, and if you can think of a AWS Glue workflow here, where a source crawler crawls that source data, populates the Glue data catalog with your with that sort of source data detail. The Glue job sucks in that data from its location, and it knows where it is, and it knows all the columns because it's been crawled by the crawler, and the data catalog has been indexed, been populated. It does its sort of transformation, writes that out into the long-term storage, and then you have a final crawler that crawls the long-term storage to detect any changes that might have been made in that Glue job. And so, and I want to emphasize, and I get questions a lot about why are there two crawlers, and I want to emphasize it's because your data actually has two representations. It has its source representation, where maybe everywhere it has every single column and every single table, and then you have your data lake representation, which is essentially the transformed version of the extract, transform, and load process. So you may choose in your Glue job to drop columns that aren't relevant or maybe are sensitive that come in your data set. You may choose to add columns by enriching it, with your own data. There's a lot of things you can do in that Glue job, but at the end of the day, you're going to have you may have a potentially different metadata, or you might have a different data set to some, it's been transformed to some degree. And so you need that data lake crawler to be able to crawl that data lake location at a second time to make sure that second representation, the data lake representation, is reflected in your Glue data catalog. So enough with the diagrams. Let's move to the actual console and show you some of this in practice. Now I want you to I'm gonna jump back for a second. I want you to remember this visual here before we jump over to the AWS Glue console, as you'll see what one of these sort of enrollment sort of patterns looks like in the console itself. All right, so let's pop over to the console now. All right, so for those of you who, so we are now inside the AWS Glue console, and I'm looking at the workflows section here in the Glue console, and I've picked a particular enrollment pattern that I've deployed. And as you expected, or as we saw illustrated in the diagram, we have our source crawler here, right, which is crawling the source representation. In this case, this is a Postgres database that it's pulling from. It is then, once that data has been crawled, a ETL job, our Glue job runs, which is this guy here. And then once the Glue job is complete, transforming the data, converting it to Parquet, compressing it, and sort of essentially optimizing that data set for querying, I run the final crawler on that data lake representation of the data to pick up any changes that might have happened during the ETL process. So focusing on the crawlers for a second, I just want to give you a sense of what the crawlers look like. So I'm gonna do a quick filter here. Okay, filter's not working, but you can see here we've got effectively two crawlers. We've got that source crawler here, which crawls the source database. In which case we can see this is we're using a JDBC connection. This is the include path on the database itself. And that's really all you need to supply for one of these crawlers to crawl your database and index it. And then you can see our data lake crawler is slightly different in that it's crawling an S3 location as the data has been transformed by our glue job. We want to crawl it in the S3 location. And so building crawlers is a really straightforward thing. I strongly recommend you try to build a crawler on your own data set because once your data set's been crawled, you can start to query it immediately. And that's going to be the next demo that we get into. But just to tie off real quick, the jobs element, the job section here on the left, you can see what a job looks like from a script perspective. This is, for those of you who've used Spark, this is going to look very, this should look very similar to what you've perhaps used in the past. For those of you who haven't used Spark before, don't be intimidated. This is a 56-line little script that copies entire databases that will work for just about any generic, Postgres, Oracle, MySQL data set or data sets in S3. So don't be intimidated. There are tools to help you author those jobs now. The AWS Glue Studio is a new feature that makes it easy to basically build and kind of through a visual job builder. You can write Spark scripts, just kind of clicking on columns and saying, yes, give me these, and joining with other data sets. So check out Glue Studio when the time comes to looking at writing your Glue jobs. But in the meantime, once your workflow is executed and your crawler and jobs are complete, it's time to start getting value out of that data. And so before we demonstrate that, just a little bit more theory. So I want to focus on the data access layer, and this is really where I want to emphasize where the difference between your data lake and your data access layer reside. Where I strongly want to emphasize the difference between your data access layer and the data lake. The data access layer is responsible for the query engine, things like Presto, for example, that take SQL and return data, right? The data access layer needs to support JDBC and ODBC for some of the reasons we discussed earlier. And then the data access layer needs to have direct integration with the Glue data catalog. And you'll see on our next slide that every service that I talk about here in a moment has direct access to the Glue data catalog. So once your data has been effectively indexed or has been cataloged in your Glue data catalog, any of the services that I talk about on the next slide will immediately be able to query that data, and we'll show a demo of that in a moment. And then finally, because the data access layer isn't actually persisting anything, the data is being persisted in your data lake in that S3 location, the data access layer can be ephemeral. So let's jump into those services and I'll kind of emphasize what I mean by ephemeral a little bit more. So there are three primary services that you want to think about fulfilling your data access layer requirements. You want to start with Amazon Athena. That's all we're going to talk about today, because Amazon Athena can take you very, very far without needing to use some of the heavier, more complicated, but arguably more powerful tools like EMR and Redshift. All of these tools support JDBC, ODBC connectivity, so you can connect your own tools to it. They all support direct integration with the Glue data catalog, so that any data that's indexed in your Glue data catalog, you can start querying immediately from these data access layer tools. To just kind of briefly touch on the differences between some of these things and perhaps why Amazon Athena is such a great place to start. Amazon Athena is completely serverless. You're paying per query, and we're going to talk a little bit more about costs in a moment or at the end. But it's completely serverless. There's no operating system that you need to worry about. You can just basically start issuing SQL directly to Athena and get your results and pay fractions of a penny for the privilege. When in the event that your access pattern calls for more like in-memory type of Spark queries or anything to that effect, Amazon EMR has direct integration with the Glue data catalog. It is cluster-based, but it gets you the ability to use, in-memory Spark or MapReduce for those types of, distributed computing requirements. And then if you have a phenomenal amount of data that needs to be reported on in a more traditional columnar data warehouse type of format, where you are at petabyte scale, Redshift is really the most cost-effective and performant option for that. But emphasize again, you really should start with Amazon Athena and then take a look at EMR or Redshift when Amazon Athena, when you start hitting performance limits. And I think you'll be pleasantly surprised how far you go without necessarily needing to use some of these conventional cluster-based technologies. And on the analysis layer, you can query this data via, from Athena or EMR or Redshift from really anywhere you are. If you're more of a data science person and you enjoy working in Jupyter or RStudio, there are libraries that you can use that really simplify working with Athena, and we'll show a demo of that in a moment. QuickSight or Tableau, like your own generic BI tools, we'll demo QuickSight as an example in a moment. But you can also query this data straight from EC2 if you needed to, straight from your own laptop. There really isn't a limit as to where you can get this data from. You can even start to explore your data directly from the AWS Management Console. And so with all that teasing, let's actually jump into the console here and show you what querying this data lake might look like. So we're now in the Athena console. So inside the AWS console, and you'll see here that now that my data sets have been enrolled, I see that source representation of the data and the data lake representation of the data. You almost always want to sort of query that data lake representation. You can also query the source data if you like, although generally that glue job is, converting your data representation into like a Parquet format and compressing it. And so you'll actually get better query performance when you query that data lake model than you would if you were querying the source data itself. So what I'll do here is I'll just kind of, you pick the database that you're interested in. So in this case, let's do our Kimball data set. And let's look at the infamous activities table. And with that, I can essentially write SQL right here inside the AWS console. And that's going to give me, return the data that I'm most interested in here. I can kind of expand these and I can look at all the different columns that are associated with this activities table. And if I click these triple dots here, there's some additional benefits. I had clicked this preview table button to make this query appear here automatically. And so this is nice. This is convenient in the event, if you set up a crawler and crawl your own data, you can, if you come into Athena and you make sure you set up your work group as sort of, there's a little helper link here to define what that means. But you'll be able to start querying your data in under 30 seconds once your data is indexed by your source crawler. And so, strongly recommend you check out using a crawler on your own data to start your journey. Now, it's not a one-trick pony here, so I also want to show you what a querying Athena out of a notebook might look like. So the tool is that we have a managed notebooking environment as part of SageMaker. And so here I'm launching the Jupyter Lab interface on a managed notebook that I've launched before. And I've got a little script in here that uses a library called PyAthena. PyAthena is a simply installed through pip, just as you would expect. But what PyAthena lets you do is PyAthena has integrations with Pandas and NumPy in such a way that it provides a connector and the ability to read SQL, a read SQL method where you can provide your SQL directly inside your notebook, which will return a data frame like a Pandas data frame, which you can then manipulate and do, full-on data science to whatever degree you might like. There is I'm going to cut over now to a really cool notebook that my colleague Sean Murphy put together to kind of show you what maybe a more sophisticated notebook looks like using PyAthena. So I'm going to pop right over that, just bear with me. So this is an example notebook using PyAthena that demonstrates very similar to what I was just showing you here, although Sean has taken the liberty of kind of implementing some actual scientific rigor into this. And it's interesting just to see how you're able to, start to approach more data science directly from Athena and able to, pass those data frames, Pandas data frames into your preferred plotting libraries to do all sorts of nice, sophisticated data science plotting and whatnot. So that is what perhaps a more sophisticated notebook looks like, using PyAthena and querying that data and manipulating it and operating in it, just like you would any data frame in any kind of common notebook environment. And then finally, I'm going to pop over to QuickSight, just as another demonstration of how once your data is in the data catalog, that you can pull that data into just about everywhere. So that same data as the web console, if I were to use our AWS, if you were to use EC2 or your own laptop, you'd be able to run the exact same queries. But when you're in the AWS ecosystem, you're able, a lot of all these services like the AWS Glue data catalog become first-class citizens for a lot of our other tools. So, for example, QuickSight is our managed BI tool for you, and this lets you do things like join data sets, join tables to create analyses. And so perhaps most importantly, you can start adding data sets from other databases like Open Targets, for example, in this case, which is originally a CSV and bunch of CSV and JSON files with data that comes from originally Postgres databases or Oracle databases or even data streams of your own. And by doing that, it gives you a lot of control to start basically living that dream of joining data sets that came from different domains or different folks and putting together your own sort of analyses on that data in a very easy to use kind of click and drag BI type of environment. So here we'll see a distribution of p-Kimball values, very similar to what we saw in the notebook. So I'm able to do that right inside of QuickSight, just like I was able to do it inside of a notebook, but perhaps you're able to use folks that are more comfortable using conventional BI tools as opposed to data science libraries can do so on that same data. All right, so that's how, so I just showed you how to query the data 3 different ways, using the console, using QuickSight, using a notebook, and I want to emphasize again that you can do that using directly from EC2 instances that you're already running. You can also query that data through Athena on your own laptop if you need. So for those of you who want to get started, hopefully this is starting to tickle, starting to tickle your interest a little bit. And you're kind of interested or maybe eager to start playing with some of these tools today. And so the AWS Registry of Open Data has started making this even easier for you to start playing with some of these tools. The way that we're doing that, and just to be clear, the AWS Registry of Open Data is a program that we have where AWS supports data transfer and storage costs of popular open data sets. And some of those data sets are, and this is a bit of a mouthful, so I'll kind of go slow, are Athena ready They are generally chemical and genomic databases, and they're basically available for free in the AWS Registry of Open Data. The ones that are available today are Open Targets and Kemble. The GTEx and Binding DB will be coming soon. We're very eager to know what other customers are interested in adding next. With those like ClinVar and other things to that effect. Please reach out if you've got an idea of what you might be interested in next. But the way this works, and this is where hopefully you guys, those of you who want to follow along and want to start playing with your Glue data catalog, we're going to kind of deploy this into an account, and it takes about 30 seconds. So for those of you guys following along, pop into your AWS account, and you'll be able to do this. So you'll be able to do this with me. So let's go ahead and initialize perhaps your data catalog for the first time with a data set that currently lives in the Registry of Open Data. So the first thing that we'll do here is go to the AWS Registry of Open. It's just registry. You can Google it, but it's registry.opendata.aws. From a data set perspective, the two data sets that are live right now are Kemble and Open Targets. And so you can just type Kemble into the search box. That's going to take you to the listing page. And the kind of documentation URL, this one right here, is what you want to click on first. This is going to have the install instructions, but to essentially describe what's happening is the data has already been transformed and stored in that long-term persistence form and optimized for querying with Athena inside of an S3 bucket that is managed by AWS. All you're going to be deploying to today with these cloud templates is the entries into your own Glue data catalog. So we're creating the entries for the tables and the columns, et cetera, but the location is the AWS S3 bucket itself. And so you'll be able to run queries with Athena through, as your data access layer against the data lake that is the combination of your catalog with the backing source just being an AWS RODA account. This could absolutely be your own S3 bucket for your own data sets, but in this case, we're just taking advantage of the open data buckets that are available now. So it's quite straightforward. All you'll need to do is pick the data set that you're most interested in here. So in this case, we'll continue with Kemble. You click that launch stack button. That's going to take you to CloudFormation. CloudFormation is our our primary infrastructure as code service. I just click that create stack at the bottom. What's happening here is there's a template that defines the Glue data catalog changes, which is currently what's getting deployed right now. You'll see very quick that deploys very, very fast. And all it's creating are those Glue tables inside your account across the board. And once that's done, right, I haven't had to do any, all I had to do is deploy that CloudFormation template. If I go into Athena, and just again, as using this sort of console browser as the easiest tool, you'll see here our 2.7 data lake RODA data set is deployed. I can come in here and start running queries against this data just like I did before, and I'd start getting, I'd get my query results in there. And I could similarly do that with QuickSight or my own laptop or an EC2 instance. Really, the world's your oyster to pull once you've got your data available to query through Athena. And just to back to the Glue console to show what we actually created with that, again, it was about 30 seconds for that template to deploy. You'll see here that we've got our database that we just deployed. That's what the CloudFormation template created, as well as the tables. Inside of these tables, the column definitions are also there. And you can see the logo, that AWS RODA data lake. And that's all we had to do. And so at that point, you can, if you follow along, you can start using Athena to query this data. If any of these data sets look interesting to you, feel free to play around with them. They're there and they're open for you to take advantage of. Now, moving on, I mentioned with promise I'd talk a little bit about security and cost. One more emphasis point that I wanted to make about security. If you remember, security is a responsibility of the data lake, right? It's not the responsibility of the data access layer or the presentation layer. And the data lake security is distinct from the source security, right? Your source security, it might be a database, it might be an S3 bucket, it might be an S3 bucket that is owned by a CRO, right? That you yourself don't control the permissions of. They grant you access to. That's how it's supposed to work, right? They maintain their own security. They're responsible for it. They're really giving you either like access security groups or access usernames and passwords to get to the underlying source data. The data lake itself, though, once that metadata is defined, you can use AWS IAM and lake formation to restrict access to your data based on your metadata. So, for example, you can restrict access to specific databases, to specific tables, to specific columns using IAM and or lake formation. Those permissions that you define there extend across the data access layer into the presentation layer, such that the tools that you're using to query that data are actually sending their credentials through the data access layer to the data lake, and the data lake is enforcing security. And that's important because you don't want to have to be rebuilding a security layer for every new data access layer or presentation tool that you build. And how those security credentials make their way through all the way through the data access layer into the data lake, that's a little bit beyond the scope of this presentation, but I will emphasize that it's a lot more transparent and straightforward than you think it might be, and you're able to define that security in one place as opposed to having to reinvent the security wheel every time you have a new cluster or Athena environment or presentation tier. I would be remiss not to mention that there are really two modes for security. The IAM only approach, which is really kind of the default mode that everybody's data lake on AWS using these tools follows, gives you the ability to kind of grant permissions at the database and table level. Oftentimes that's enough, right? That might be as granular as you ever need to go, in which case you may only ever need to focus on IAM-based permissions. The granting policy, like how you give permissions to others, that's all IAM-based. You're giving grants through IAM. The IAM lake formation extends that security model of IAM and gives you the additional ability to define granularity at the column level in addition to the table. So you can do column and location, and the lake formation team is always improving, and so there'll be more granularity as lake formation evolves over time. And it's also got a more sophisticated grant process, so that if you do have heavy needs to be very precise with who can grant permissions to what, or very column level permissions, lake formation is going to be in your cards. You'll need to take advantage of that. But if you don't need that at the outset, just use IAM at the beginning. You can always extend and start taking advantage of lake formation down the road when you need that additional granularity. All right, so a little bit about the unit costs of what we're talking about today. Really, everything that we're discussing here is more or less serverless. The notebook is really the only thing that is the closest thing to a server that we used. So everything is basically pay per SIP. So we're storing 7 gigs of storage. It costs 16 cents a month for the Open Targets data set, for example. The glue crawler to run, the glue jobs, those are relatively low cost. You can see the net effect of not only enrolling the data, but using the notebook to analyze it is effectively $3. So the unit costs of this are generally much lower. It's going to be your HPC infrastructure down the line that's crunching your data out of your data lake that might end up being the cost. But the data lake itself Athena itself can be extremely cost efficient. All right, so moving forward and wrapping up here, where do you get started? You know, I give you a lot of theory here, and I want to give you some very prescriptive suggestions at where to start getting hands-on with some of these tools. And the first place is a crawler. Go into the Glue console, start playing with the crawlers. If you've got a data set in an S3 bucket today, set up a crawler to go crawl that data set and start trying to query that data with Athena as the second step. Let that crawler catalog your data into the Glue data catalog, and once that's done, you can start querying the data. You may find that it's very effective, and you may create a crawler for a different data set and start to join those things together, and be able to just take advantage with just that, right? Once you're able to sort of play around with the crawler and you're able to query that data, if you start feeling performance limitations of that, or you realize, yeah, maybe I need to convert this into a Parquet format because my data is more columnar in nature, that's when you want to start looking at the Glue set. Try setting up a Glue job. A Glue job, use that Glue Studio. It makes it so much easier now to write really high quality jobs without having to know a lick or write a line of code. So, but do that second, right? Try running the crawlers first, try querying the data with Athena, and then take a look at the Glue job. And I would suggest that you kind of hold back or don't try setting up a Glue workflow yet. That was one of the first things I showed you, just as a kind of conceptual, this is what it would all look like when you put it all together. But until you're ready to start setting up, applying some rigor to the way that your data is loaded on a regular basis, or adding the notion of like checkpoints and a little more process, that's when you want to start using a Glue workflow. If you're just getting started, start it with that crawler, start with Athena, and then maybe start playing around with the Glue job. For those of you who are a little more, who are kind of understand this and appreciate infrastructure as code to the same degree I do, may want to, or maybe already have the need or understand that there's the need to have, you're eager to start applying some of that rigor early on. The AWS Cloud Development Kit, in my opinion, is the future of infrastructure as code for AWS. And what we've done there is we've built a number of constructs that you can instantiate yourself and take advantage of or extend that effectively build out that enrollment workflow that we depicted earlier for you, following all the AWS best practices, setting up all the IAM requirements, following this sort of crawler pattern in a tight, very easy to use construct. You can see the GitHub repo down there. This isn't something that I recommend everybody start with until they've had a chance to appreciate and get hands-on with the Glue console directly. You'll, I think, see why using a construct like this to automate stringing together these workflows is a much easier way to manage your data set. And just, this wouldn't be a proper talk without at least a snippet of code. This is an example of instantiating that S3 data set enrollment construct, which you can see depicted here. All you do is you basically say how much gas you want to give the job and where your tables are. And that will set up the crawler, the job, the data lake crawler, the workflow, all the triggers, all the IAM permissions to allow your crawler to allow this workflow to index your data. And then for those of you who are already CDK pros, you'll appreciate we've implemented very simplistic grant read type in the CDK style method, to where a single grant read method will grant all the necessary privileges to an IAM user or role to be able to consume the data using Athena or Redshift or Glue, or Athena, Redshift, or EMR. And the grants extend to not just the IAM, but also the lake formation extensions as well. So if you can capture, you can kind of live that future dream where I have customers that are using this today that have all of their grants captured in code, checked into their code repository, and when audit and review time, security review time comes, they're able to look at very explicitly all of the grants that they've granted to people and make changes as necessary. So having both your infrastructure and your security permissions captured as code really puts you, is really the kind of next level of where what the data lake as code CDK constructs make possible for you. So don't want to overwhelm you with those last ideas. If that feels like too much, that's fine. Want to wrap up with some final thoughts here. Want to just emphasize that data lakes are a concept, not a specific service. You're not going to go into the AWS console and find a data lake service. Anybody who's selling you an individual product that says it's a data lake is likely misconstruing what they're doing, right? You can start with pieces of your data lake and things like the Glue data catalog and Athena, and start getting value out of some of the services as you build into more complicated and more sophisticated architecture patterns. Want to emphasize that, understand what a data lake is and what it isn't. The more that you respect the separation of layers between your data lake and your data access layer and your presentation layer, the easier your life is going to be over time. For example, security, by emphasizing that your security layer needs to be implemented in the data lake, you're not going to have to reinvent the wheel from a security perspective for every different data access layer or presentation layer that you come in that you use over time. Finally, just get started with Amazon Glue and Amazon Athena. I can't emphasize enough that just playing around with the crawler and Athena and the Glue data catalog, you're going to be able to start querying your data, much faster, the right way, across all different types of data access patterns that you may need over time. And that's something you can do in the console today. So don't hesitate with that. And as things grow, as complexity grows, and you need more emphasis around things like infrastructure as code, take a look at things like the data lake as code CDK constructs, or some of the other data lake constructs that AWS puts out. I think you'll find that those will save you time in the long run. And really the most important thing that I can emphasize to all of you is talk to your AWS account team. Every AWS customer has the has the ability to talk to an account team. That account team includes an AWS solution architect, very similar to myself. These people can help you think through, these individual pieces of the data lake or your whole data lake strategy at large. If you don't know who your account team is, check out that contact us link at the bottom. They can connect you with an account team. And these account managers and account SA solution architects can connect you with service teams, or really help you unravel what anything that might have been unclear today. So thank you very much for your time today. If you're interested in a couple of follow-ups, feel free to check out the GitHub repo with the data lake as code. If you're interested in a little more sort of narrative about some of the concepts we talked about today, check out that blog down below. And also don't hesitate to check out the Registry of Open Data, the Kimball and Open Targets listing like we went through today, in case you want to start playing with some of these things using open data sets. And thank you very much. My name is Paul Underwood, and it's been a pleasure presenting to you all today. Thank you.